Hello, everyone, and welcome to today's Thomas Tool Tuesday. We're going to be talking about some new stuff that's come around in the past few years. This one came out in 2019. This particular tool, this is Northern Illinois University's Practically Perfect Hindcast. So we're going to be talking about that a bit more here as we move on. But before we do that, we have to start with what Storm Prediction Center outlooks do. Their primary purpose is to predict the future. So when you look at an outlook, you're looking at what the future is supposed to look like. The outlook I'm showing you now is the iconic April 27th, 2011 tornado outbreak outlook, the day of a 45% tornado risk, a famous high risk outlook. Today, we're going to be talking about the tool that lets you look back in time and see how close were we really when it comes to these outlooks. So let's begin. This is the Storm Prediction Center Practically Perfect Hindcast. That's what we're looking at. It's courtesy of Northern Illinois University. It basically takes storm reports and turns them into SPC Outlook maps, the same sort of color scale, the same sort of graphical style, so you can see how exactly the Storm Prediction Center performed. Now, this site right here is actually the one that tells you all about it, but it's not the site itself that we want to look at today. The main one, it's the URL here up on the top. It'll be in the description of this video as well, but it gives you an idea of how these look. So here, side by side, we have the Practically Perfect Hindcast for April 27th, 2011, and we have the Storm Prediction Center Outlook. So what do we notice? Well, when it comes to the Hindcast, we have a 60% contour that is ginormous, stretching all the way from Mississippi all the way up to Tennessee, and I'm expecting that we're going to continue to see outlooks a lot like this, where we have these focused, high probability zones as you take a look. But here at the Storm Prediction Center Outlook, take a look at that. We have a 45% zone that is encompassed in their 60%, but the 2011 super outbreak of tornadoes, of course, was unprecedented in nature. So it's not totally surprising that we're seeing a bit higher probabilities here when it comes to the verification of what was given here. The other thing is this notable cluster of tornadoes in the Northeast that was not captured here when it comes to the Storm Prediction Center outlook. What we saw in the SPC outlook was more of a low probability sort of thing. So it's interesting to see how those probabilities tend to be higher as you look farther into the specifics, and it tends to be less widespread, but that is to be expected. We're not the most precise when it comes to severe weather forecasting just yet. So now I want to take us to a website here. This website is the website that we'll be using for the Practically Perfect Hindcast. And you'll notice it goes to 2019. So this website's really fun. I have, again, the link to it in the description. If you're familiar with Python or programming, you can get data all the way to 2023. However, this website only hosts up to 2019. So let's take a look at it. Let's take a look at a couple of fun days just to see what we have. So to start, we have May 20th, 2019. You can look on this calendar tool, and you can look here, how did this actually pan out? So this was famously a 45% hatched high risk for tornadoes, heralded to be a very bad day for the plains. It did end up being a bad one, but not as bad as it could have been. So here's a look. We did have a 45% tornadic probability, but you'll notice the significant tornado probability was not super high. We look at that, and that is what we see indeed. If we go to 2018, December of 2018, December 1st, that was when the Taylorville EF3 tornado happened in a cold core setup. That was over in Illinois, so we can see what precisely we see there. And you'll notice that verifies as a high risk with a significant tornado risk there near Taylorville. That's actually the first tornado emergency I ever tracked. So that's cool indeed. As we move back in time a little bit, go back to 2011 now, or 2013. Let's go back to 2013. We can go to May 31st, 2013. That's the El Reno EF3 and the St. Louis EF3. And you'll notice both of those are well captured, that moderate to high risk verification for tornadoes. The hail was pretty bad in Oklahoma as well with these supercells. And you'll notice we had a bit of a squall line that moved through Illinois. That's captured here pretty well by that 60% wind probability. So this is very fun. You can look through and see kind of how did past events you are interested in pan out. Of course, we have the tornado outbreak sequence in 2019. The final thing I'll look at, just because I'm sure people are curious there. starting from, I think it was like May 15th-ish, maybe a little later. But May 17th, there we go. System starts out in the plains. The 18th, there it is. The 19th, 20th, 21st, 22nd. And this was a bit of an outbreak sequence that happened here. I know the Lawrence, Kansas EF4 happened around this time. This was a very active period in severe weather. But yeah, you can look back all the way back to around 1955. So let's say you wanted to look at the other super outbreak that we haven't touched on yet, April 3rd, 1974. And there it is. I mean, just a massive 60 hatched tornado risk. I mean, it's no wonder given just how prolific that outbreak was. But you can also see how the wind and the hail reports would have verified as well. So very impressive website, a very fun tool to use, and one that I anticipate we will continue to take a look at as the years go on. There's a running 90-day archive of this as well. I will put that in the description. So if an outbreak just happened and you want to see what that verification looks like, there's a live updating archive. So why is this a cool tool? What makes this such a useful piece of information for us? Well, the main thing is primarily that it gives, for an atmospheric science student like myself or you, it gives us an idea of what a 10% tornado risk or a 15% tornado risk actually looks like. What's a moderate risk for wind actually look like? When it comes to verification, if you make your own outlook, you can see how right you were. And that's really important as well. But there is a caveat to all of this, and I want to go over it. It's very important. This tool is not perfect. It is not exact. It's called the Practically Perfect Hindcast because it assumes that if storm reports were gospel, let's say that that is exactly what happened during a day, this is what the probabilities would look like. But as we know, storm reports aren't always accurate. So sometimes you get a bunch of reports for one event in close density, that's going to inflate your probabilities. If we had, let's say, a missed hail event or a missed wind event on the Storm Prediction Center storm reports, that's going to deflate probabilities. So it's by no means perfect, but it's a very useful tool for us, something that I anticipate we will continue to use as we move through the next many years, as it is still useful nonetheless. In general, in my personal experience, it tends to overinflate probabilities a little bit. So just keep that in mind when you're verifying your forecast. If you didn't go aggressive enough on your risk categories or placements, just know that hyperlocal events do influence the way that these maps end up panning out. So let's have some fun now. This is May 20th, 2019. We talked about it. This is the Storm Prediction Center Outlook. 45% hatched risk going all the way from Texas into the Oklahoma City metro. And this, of course, was not something that verified here. We had a day that encompassed the Megam EF4 tornado, and that was about it. That was about it. This thing squalled out. We didn't see the widespread supercellular tornadic activity we were expecting that day. This was a day that didn't quite live up to expectations when it comes to the Storm Prediction Center Outlook. Let's move to the next one. This is May 22nd, 2011. You'll notice there it is, that high-risk verification down in southwestern Missouri. That is where the Joplin tornado occurred. So, of course, bad day, a famous EF5 tornado. Let's take a look at what the Storm Prediction Center had. They mainly had the worst of the risk being farther north from around the St. Louis metro, the Columbia area, all the way up through around Chicago, Cedar Rapids, up towards Milwaukee, and that's where we saw the highest risk from the Storm Prediction Center. Still verified okay, actually, if you take a look. We actually had a high risk significant tornado verification up there, and that was actually a fairly prolific outbreak. The thing is, though, of course, the Joplin EF5 stole all the attention, and that was not well forecast by the Storm Prediction Center. Still, though, significant tornado risk nonetheless, so we got to give credit where credit is due. Let's look at the final case. This is March 12th, 2006, known as the most prolific tornado outbreak in the history of the state of Missouri. You'll notice it did verify as a 60% tornado risk in a very small region, definitely warranted a 45% tornado risk the day of. If you take a look back at the outbreaks, numerous F2s and F3s that would definitely make it worthy of a high risk upper echelon tornado outbreak, again, especially for the state of Missouri. Storm Prediction Center did a solid job here, a very widespread 15% and 30% contour. The region of where the worst of the tornadoes did occur was within that high risk. This was very well drawn, a bit too large of a spatial area to the south here when it comes to the tornado reports, and a bit too far to the east. But again, these things are hard to predict, so it's really fun to look back, see how these reports did verify as you look back at previous events. And we can do this again and again and again. There's so much to look through from 1955 to 2019 to see how did the Storm Prediction Center do, and if you made an outlook, how would you have done? So all interesting things indeed. Well, now that we've looked at this tool, again, the link will be in the description. Next week, we're going to be going over the meteorological conversions calculator, courtesy of the National Weather Service. This allows you to convert units for temperature, wind speed, other variables. It also allows you to calculate wind chill and heat index. So I'll be going over all the features of this web page when we start Thomas Tool Tuesday next week.